Do I need the mic? Do I need the mic? No.
Use the mic. It's on here too.
Oh, okay.
I wasn't expecting to, but I think we are, yeah.
And you should probably use it.
That's fair. Sound all right? Sound okay? Is it coming through the, not too loud, not too soft? Great. Guys, thank you so much for coming today. My name is Chase Horvath. I am a solutions engineer at Confluent. My day-to-day job is working with game companies to improve their telemetry. So I work with some of our largest customers like Epic Games, like Ubisoft, Activision, Blizzard, those sorts of companies. And what game telemetry is it's what is happening in the game. How many of you guys game habitually, not habitually, for a long time? Right on. All right, I've been gaming since I was a little kid. All sorts of games. I love to create games with my brother. When we were little, we couldn't afford like the Warhammer tabletop figurines. We'd make them out of clay and play that. We'd tie strings to them so we didn't have to measure stuff. So gaming is very much an industry of love. And we're going through some changes, and I'm going to talk about those changes. So I'm going to go fast. I hope this doesn't take a whole 30 minutes, but I got a pretty cool demo to show you. So I'm going to talk about what we do in gaming with our data, why Kafka and Elastic fit in there, and why specifically Confluent Cloud and Elastic Cloud are great choices. We'll look at what I usually see in the field, like what are these people actually doing? What are my customers actually doing with these products? Look at some challenges with that, some challenges currently in the industry, how we're going to overcome those, and then I'll show you a sweet demo. So in gaming, we have lots and lots of data. It's a very data-driven business. You can take telemetry as detailed or as not detailed as you want, but when we talk about gaming telemetry, it's what people are doing in the game. What are they having trouble with? What items are they using? Who are they talking to? What are they saying? Where are they? What features are they using? But we mix that with storefront data, identity management from third-party sources. Because imagine I'm a game developer and I need to deploy my game on Xbox and PlayStation Live and then across the Epic Game Store and on Steam. There's a lot of identity management and cross-platform data that comes in. It all comes in different formats, comes from different sources, and we need to unify that. And then you mix that with everything else that a normal company needs to do, like infrastructure monitoring and all that kind of stuff. So we use this data to kind of do three big broad categories of things. One is to engage our gamers. How do I make better friends with these people? How do I make them more loyal? How do I give them a better experience, And then I want to monetize their experiences. So I've made these great experiences, and now I need to make sure that I'm making money. Gaming is definitely an industry of love. I'm in it because I really like it, but I still need to eat, and unfortunately I can't live off pizza and soda because it will just kill me. So we need to make money off these games. Also, the games you've seen come out lately are like 4 times as big and cost 4 times as much as they used to, and that's becoming a big challenge in the industry. So we need to figure out how to correctly monetize these great experiences we're making for our customers. And then kind of one of the other things we do with our data is enhance the game development lifecycle. What do I need to make? What platforms do I need to target? Are my players happy? What functions are they using? And that's very much in like the line of like a clickstream from a website or any other tool. That's a pretty standard use case across industries. Gaming companies are often very small, and they have a lot of challenges that larger companies have. It's kind of a unique situation to be such a small company with such a global reach. So I need to do things like comply with local laws and translate this game into many different languages. But I'm such a small company. A lot of these studios are like 40 people at max. And if you ever go back and beat the old like Super NES, Super Mario World, I think it's like 16 people made that game. So that's kind of telling you the scale of what games are made at versus the challenges they have to overcome. So we also have challenges with scaling. A company of that size normally wouldn't be so concerned about having to scale up to, say, ingest gigabytes a second of data, but we have situations in which all the kids get off school on the East Coast, and then that wave of influx of players just continues, and it continues to scale up and grow until well after dinner time in California. So we have these 0 to 10x scaling in the same day, and you can't deploy all that infrastructure and run it all the time because you're a small company, your game's not selling for that much, and you just kind of go broke. So we have these sorts of challenges that we need to overcome. Here's a list of use cases I've worked on with my customers. I've just kind of put the coolest ones in red. But the thing you want to look at here is think about the real-timeness of the data when it comes to these. If I have a cheater, or if I have someone who's being toxic and chasing other players out of the game, causing a bad experience, the longer that person stays in the game is the more people they are going to ruin the experience for. So I need to pull them out as quickly as possible. If I'm looking at matchmaking, I need to be able to instantly match people in a multiplayer game with people of their same skill level, same play style, so that they can have a good time. Otherwise, they're going to get frustrated and leave. So the real-timeness of this data actually has a huge impact on the player, which is why products that have a low round-trip latency or a low ingest to consume latency like Kafka and like Elastic are really good solutions here. So in these pipelines and in this data, we love it when we see Elastic because they're a great partner of ours. But we use Kafka because Confluent is a Kafka company at its core. And Confluent Cloud in particular because it provides an entire data streaming platform. How many of you guys are pretty familiar with Kafka in general and data streaming? You understand what an event is? Awesome. So an event it's a piece of information that was true at a certain point in time, right? So my shirt is kind of the start color blue. I might change it, and then my shirt will be a shade of red or whatever. And so we mix facts with time, and we stream those in real time. And we stream those, and we can do processing on those. We can do governance on them, make sure they're of high quality. And then we send those to a product like Elastic Cloud, which helps us do the analysis on the data. And these two products fit really well together because they can scale really rapidly, which means I can deal with those 10x swings on the daily, and I can deal with a 20 to 40x swing when it comes Christmas break or Thanksgiving when everyone's off of school. They have really high throughput capabilities. I can pump gigabytes of data through both of these products, and they'll handle it with grace. So there's a lot of synergies there that work really well. What I see in the field is a setup kind of like this. On the left side are the like the data producers, right? These are the things like game clients and websites and backend services and stores and stuff like that. And we collect this data and we get it into Kafka. Kafka is like more or less the lines on a lot of architecture charts, right? So we have some that are direct Kafka producers and some that we do what we call change data capture off of a database. So in this example, I've got a web store in the bottom left. Not a native Kafka app, not producing real-time streaming data, but we put a connector on the database that it uses, and we actually capture changes to tables in that database, such as user phone number updates, such as purchases, or things like that. Then we can turn them into events and feed them into Kafka. We can mix them with the other data that's coming from the game clients and the game servers. And we can do stream processing, that mixing, that filtering, that enriching. Is called stream processing. And I can also do some really cool like windowed functions and stuff like that. But then I add governance on top of it to make sure that the data is a high quality. And then I ship it out. And the most common destination for it are things like Elastic Cloud, Snowflake, Databricks, those sorts of things. We get the data into them, and then they can make insights off of that data. They can help us make decisions. You're going to see a lot of really cool charts at the end of this. And you're like, well, that's great, but this is not being acted on in real time. That's because I'm trying to visualize the data for you. It's systems like Elastic that help us make decisions in real time based on that data, based off deep insights. So the data comes full circle. You see the line that actually goes back into the Kafka land in there, back into Confluent Cloud land. And then now that it's in there, it can be administered, kind of distributed out to all of the other consumers that are native Kafka consumers that are taking actions in real time in the games. If they detected a cheater, we remove that person from the game. If we detected somebody stuck, we want to stop their frustration, we grant them a free item that gets them past this level so that they stay in the game and they stay in love with it. So that's a very common architecture, but there's some problems with it, and there's some problems with the industry right now in that we are going through a post-COVID contraction. Still, there's a lot of layoffs. The cost of doing something like this is incredibly high because you have a lot of data being stored, you have a lot of systems, you have a lot of processing. And as a person who works for Confluent, as a Kafka person, Kafka is my hammer. I need to make that hammer more efficient. So we are working to decrease the cost of Kafka because it's a primary cost driver in a lot of these pipelines. So what we did is we came out with an entirely different paradigm for moving data and streaming, and we call that a freight cluster. And what we did is we changed the inner workings of Kafka to, we gave up super low latency for a lot of cost. So we added about a second of latency, and we dropped the cost by about 50%. And that's the trade-off there. And you might be thinking, well, 1 second is still pretty tight. Yeah, it is, but normal Kafka, you can tune it, you can get like 50 to 100 milliseconds ingest to consume. Like that's the kind of stuff where if I'm playing on my phone and I'm mad, they can catch me between when I get mad and when I put that phone down. That's that latency, but this kind of latency is still good for a lot of topics like big analysis on feature utilization, on toxicity detection, on things like that. So it's still broadly applicable to most of our use cases. How we did that, if you're familiar with the inner workings of Kafka, it's got brokers, you put them across availability zones. These brokers are usually pretty beefy. There's a lot of data storage on these brokers. And in order to achieve high availability, we're always replicating data across these brokers. We put the data in at least 3 places, kind of like you would expect for a 3AZ deployment of something for high availability. But what that does is it creates a lot of cross-zone traffic. And it's a lot of spinning disks. It's a lot of processing for that. So the brokers get really expensive, and the networking gets really expensive. Actually, networking is typically like 68% of a Kafka deployment's cost. So what we did is we decided, well, we're not going to spend disks anymore. We're going to make these brokers entirely stateless, and we're going to put all the data in object storage, which means I've gotten rid of the most expensive part of the data storage. Because object storage, and generally in most implementations on it, automatically goes cross availability zones anyways, I don't need to pay for cross AZ traffic. I put it in object storage in one zone, and 1 second later, it's available in zone 3 to those brokers. They don't have to store it. I didn't have to send it from zone to zone. I'm not paying for that, which is fantastic. What else do we do here? Like no more spinning disks, stateless brokers so I can scale them really quickly. We have a really strong metadata plane that's always running like compaction and optimization jobs on that data that's in the object storage. So these brokers always have really fast, good access to organized data. It's just a very optimized system. Because the brokers are so small, we can auto-scale these really easily, really quickly. If you ever tried to scale a Kafka cluster, you have to take little bits of these topics and partitions and move them manually from broker to broker. There are some automated ways to do it, but it still usually requires a human. What Confluent has figured out how to do is automate all that. It's pretty sweet, but a normal Kafka cluster is deployed 10x what you're normally doing so that you can handle those daily swings, and you're just wasting that infrastructure all day long. This allows us to right size it by the minute or by the second and saves often 70-some% on just your infrastructure costs. So that's how we brought the price of Kafka down. That's how we think we're going to be able to collect better data for video games because they're very data driven, and hopefully allow the video gaming industry to thrive because they need that data. Demos next. That's actually the cool part. Anybody got any questions before I move on?
So you just mentioned kind of like real-time scaling and things like that, and I sort of see an analog to like the utility market, and is there sort of going to feed into like surge pricing for cloud type availability for these resources?
No, actually we kind of go the opposite direction, and for some of these clusters and for some of our larger customers, we actually do take like the reserved instance model. So you guarantee us you're not going to scale below 10 units, and we'll give you a deal on everything above 10 units, like that sort of thing. So it's actually, we run these, it's a multi-tenant architecture actually. So we're able to do the math and kind of intelligently place customers that have different swings in scaling needs on the same kind of unit of that or the same core of that, and be really, really efficient with it. So no surge pricing for Kafka.
Or other like real-time data streaming solutions considered, such as Kinesis, other technologies like that?
Yeah, so Kinesis is, that's, honestly, I go in and I see a lot of Kinesis. The problem with Kinesis in gaming is scale. You get to a high scale of Kinesis, it starts to lag, it starts to struggle when you try to give it, more than 300 megabytes a second, no matter how you shard it out. Kinesis is also built for a 1 in, 2 out ratio. Kafka can do much more than that. So if I have data in there that needs to be read in real time by 10 applications, I can do that no problem in Kafka. Kinesis really struggles with that. What you have to do is create 5 copies of that data to fan it out to 10 consumers in real time. So the cost and ability of Kinesis, they hold up at first, but when you get to the gigabyte a second scale, you have to go to Kafka.
I probably ask a pretty naive question. So when you say that you put the data into object store, and then it kind of replicate pretty easily. So I assume there's a certain traffic also go through from one place to the other or not?
Yeah. So it's a new type of Kafka cluster. So we expose the Kafka interface. You could take a Kafka native app, producer or consumer, and hook it up to this cluster. But the way that the cluster, what it does with the data after it gets it, is putting it on that object storage, and it lets the object storage do the replication and handle the durability of the data.
So somehow the object store can replicate much more efficiently
Yeah.
Than like an individual.
Mm-hmm. We're piggybacking on the specialties of the hyperscalers.
And why is that? Because
so much cheaper. How much? I can store data on S3 at a fifth of the cost of what I can do it on a spinning disk on a virtual machine. So that's why we do that, and that's where the additional latency comes from. Spinning disk on a VM, really short latency. I have some customers who actually run Kafka on bare metal in their own data centers to get that latency down as fast as possible, those mobile gaming customers. But when you tier data off into S3, you have to grab it in batches, and there's latency associated with that. So that's why you look at 1 second instead of 100 milliseconds.
For auto scaling, are you scaling the brokers, or are you partitioning and unpartitioning topics as well?
So Freight has partitions just like Kafka because it's a Kafka-like interface. We can, if you want to do more throughput on a certain topic, you need to tell it this topic needs more partitions, because changing the number of partitions really affects the downstream consumers of that, and there will be points at time at which it just doesn't make sense to scale the partitions. But what we can do is, if you get a busy broker, we'll move partitions off that broker to a fresh broker, which means I can put a lot more throughput through a partition. So if my broker has a 10 gigabit NIC on it, and I'm pushing that, I move half my partitions to a brand new broker. All of a sudden, I've only got 5 gigabytes a second here and 5 gigabytes a second there. We're good. We're live again, and I can do that in a matter of seconds.
Just follow up on the latency issue there. Is there a certain way of manage kind of optimizing certain way using a mix of configuration of users, like an object store versus a more traditional way?
Yeah. So this will be the last question I take, because I really want to show you guys the demo. Okay. Yes, and actually, when you run a traditional Kafka cluster on Confluent Cloud, that is what we are doing. We store a certain amount of data on our brokers, and then after a couple minutes, we actually tier it off in object storage anyways. It's way cheaper for us. And in the instance that you need the data, we can still grab it, and the latency is still fairly low. It also makes it so that our brokers are smaller. We can scale them faster. We're not replicating as much data, faster disaster recovery, all that kind of stuff. All right, so on the demo, what I'm going to show you today are a couple of kind of simulated game server, game clients producing telemetry. I also have some marketing data coming in there. We're not going to mess with that too much, but that flows into Confluent Cloud. We're going to process it with some Flink stream processing. We're going to look at it from a governance standpoint and make sure the data is of high quality. And then we're going to take that data and we're going to use a fully managed sync connector, so it's still running. It's a SaaS product. All I got to do is configure and run it. And we shoot that to Elastic, and we're going to look at that data in Elastic and find out what we can learn from it, right? But remember, you got to remember the goals of what I want to do with this data. I want to engage my players. I want to monetize their experiences. I got to make money off of them. I need to improve my development cycle. So I need to know who my top players are. I need to know, kind of what the effects of an A/B test would be. So if I'm rolling out new features, what's going on? I need to know what platforms to target with my development. Maybe I don't want to target Switch because no one's playing this game on Switch. It's too complicated. It's too graphically intensive. I need to kind of know what features are doing the most. Is my game balanced? Where are people winning? Where are people losing? The first items in there are the producer apps. They're written in Python, and that's kind of all you need to know about those. They're producing a really cool data set. And we can look at the flow of the data in Confluent Cloud. This is the actual, like the user interface for Confluent Cloud. I have a bunch of environments here because this is my entire team. But I can look at this cluster that I have. So this is my gaming telemetry cluster. And I have this really cool tool called Stream Lineage. So I can actually see my two producer apps. There's one here, there's one here, and I can watch the data flow from these apps to these topics and finally into that Elasticsearch connector. And in the case of this topic, it's actually being picked up on my Flink statement and doing extreme processing on that data. The result is another topic that is eventually put back into Elastic. So let me get back to that cluster, and I can show you a list of the topics, which isn't really all that cool once you've seen that map. Like, all right, I got all this data from that map, but I can see data rates and stuff like that. What I want to show you next is that Flink stream processing thing. So one of the things I've talked about repeatedly is stopping player churn. So stopping someone who's frustrated with the game, who's lost too many times in a row, and send them something to alter the game experience in real time so that they stick around. And I've done that here, and this is taking every win-loss event. So every time a player finishes a game, is it a win or a lose? And it looks at, over a 30-second window, how many times has that player lost? And if it's more than, whatever I have in here, more than 8 seconds, I actually have this in a much prettier format. Here's the actual statement. So I stage the data here, and I look at it over a window here, and I create kind of a count of the losses. And if it's greater than 5, I produce another event, which is called the churn alert. And you saw that topic in the, oh, come on, stream lineage. Here's my game results topic, and there's my Flink statement, and there's my churn alert topic. The data eventually is picked up by the connector, which is a fully managed connector in Confluent Cloud, again, running as SaaS. That's not a whole lot of fun to look at in the GUI, so I'll just kind of show you the configuration here. It's pretty straightforward to configure. You tell it what topics you want, you tell it the data format. I'm serializing this to data using JSON. You give it a service account for both Kafka and for Elastic, and you send it on its way. This connector has a really cool feature where it can integrate with the schema registry, so it can translate the data types from Kafka data types into Elastic data types, and then you're off to the races. Once I get that data into Elastic, I can start making these really cool dashboards out of it. And now this is visualization of the data, but generally you would have systems acting on this. So as these insights would go back into Kafka, they would then be consumed by other systems who would take actions on it. So I want to see things like, who are my top players? And right now my top players, the player IDs are on the bottom. 10, 9, and 6 are my highest scoring players over the last, I think this goes for like 36-minute time window or something like that. So this is helping me address my player base, give this player some awards or something like that, give them fame, give them infamy, whatever they deserve. The next one, I'm looking at the platforms that my game results are coming from. So what's my busiest platform? If I need to focus development efforts, I can see that this data is not very varied, but I can see that Switch is my top platform. And maybe this game isn't really jiving with the PS5 audience. Why is that? Is the game running okay on PS5? Those sorts of things. Next is a hardware analysis. So I have the platforms, and then I'm looking at the GPU that they're using. So I see a very even boring distribution of GPUs on some of these Windows Analytics platforms. But obviously, Switch, you're not changing your GPU on because it's a handheld unit and you're not modifying it. So they all have the same GPU. And this helps me say, all right, do I need to work with NVIDIA on better drivers? If I would, in a real world, I would be mixing this data with like latency data and frames per second type telemetry to know if my game is running really poorly on certain hardware and where I need to focus my development efforts. This graph is looking at the effects of an A/B test. The scenario is I just rolled out a update or the trial feature to server 4, and look what happened to the average player game score on server 4. It rock bottomed out. This is data in real time. It's the average session score over the last 36 minutes of these players, and clearly something I put into that server as part of the A/B test is something I need to roll back. Cheat detection's kind of on the forefront of everyone's mind. I can see that player 5, this is a stacked bar chart of wins and losses. This is really hard to see. I wish I could change the scale of some of these lines, but they're just not going to change in this interface. Like player 5 actually has no losses. So clearly something you want to dive into. Is this a player that's just started and they've only won their 3 like intros and now they're going to start losing? Or is this a player that's cheating? And I can look at their actions per minute and see that this player is actually entering way more commands than any of the other players. This graph represents how many commands are given in. So if I'm playing a game, it's basically how many keys I can press at once or in a certain time. Other players are averaging less than 50. This guy's got 150, so he's clearly doing something different. Probably cheating through something. Game balance, I'm looking at wins and losses. Is my game fair? Do I want people winning more than they lose? Is that the type of game? What's my audience look at? And then feature utilization of like, this is, now you can't see the items. This is different challenges in the game, different bosses, different levels, and then different items that were used as part of those. I should really make this data a little more dynamic, but then I could say, oh look, people are winning against a fire boss when they're using a lightning sword. That's not supposed to be that way. I want them to use the water sword. Let's play Pokemon here, water beats fire. We want people using certain parts of the game to accomplish certain parts of the game. So that way I can monetize that behavior and get it right. So yeah, that's it. That's the data in a nutshell. I'm pretty sure I'm well over my time. So if anyone has any questions, I'd love to go through them.
So how, like, working with these different game companies, how have you kind of, like, had these discovery conversations around these KPIs, right? Like churn rate, like things like that. How did that start and where did that go?
Well, I've been gaming my entire life, and I've always been very interested in how these games were made and like making my own games and stuff like that. And then I'm actually not a technical major. I'm a business major in college. That was a very long time ago, but so I understand like all these aspects of the marketing and how to monetize things and stuff like that. So it kind of got to, I was talking with these game development teams and talking with the data teams of them, and then I would ask them like, okay, well, what do we need this data to do? And they'd be like, I don't know. I was just told to get this data together, and they don't have any control over what the game development teams are creating. Games are a very dynamic thing. When you add something new, you then have to change the telemetry associated with it. So the Kafka teams have really no clue what's coming in a lot of the time. So you ask them those sorts of questions, like, what do you need this data to do? And they say, I don't know, let me go get somebody. So you work your way up the chain, and like we just were working with Zynga quite recently, and their big thing was, I can't prevent customer churn, and I can't do like personalized experiences. And these are the guys who made Farmville, OG, like big time, and they can't create a truly real-time customized experience. How do we do that? So we worked with them for about 6 months and proved that we could do it, and then we're off to the races with them. And that actually really lends itself very nicely to then interfacing with the marketing teams, and interfacing with the execs who have these KPIs of I need to increase the total play hours by XYZ amount, which is very challenging right now because we're going through a post-COVID contraction. We've also had a lot of other fun toys added to the repertoire of kids lately, like Snapchat and stuff like, geez, not Snapchat, what's the other one, Instagram and TikTok. You look at industry trends and you look at the total number of screen time hours per day. That stayed pretty constant, but the number of gaming hours has actually shifted onto TikTok, which is super weird to me, but hey, you guys do what you want to do. So we're really working on those sorts of things and making better games.
Sorry, just revisiting the interoperability of network traffic.
Mm-hmm.
You mentioned before that's a particular pain point for my company as well. What sort of reductions did you see by offloading top-tier storage?
Like 60%.
60% reduction?
Yeah, because all right, so think about when you run a cross AZ Kafka implementation, every bit of data that you write to one broker has to be written to 2 other brokers and 2 other AZs. That's a lot of cross, especially if you're in AWS. That's a lot of cross-zone traffic. And you think of like, if you're taking pure JMX metrics, you write 1 megabyte of data that actually generates like 6 megabytes of cross-zone traffic. So it's, I mean, because it's not just that data, it's all the ACNACs and all that kind of stuff. So, the guy behind you, sorry.
Technical question or general. So my question is like, if you maybe one bit of context, my background isn't so much gaming. My background is more in like the media industry. So very similar, just replace everything you said with games, with news articles, and you basically have this.
Right, like or e-commerce, a lot like website clickstream, very similar data.
Yeah. So the question there is, in my experience, a lot of the stuff that you can measure in real time, but the actual choices that you make are much slower than that.
Right.
Because usually the metrics that really move the needle are much more slow moving than on the second level or what I tell you. You can go, like next day you can go in, okay, we make a different choice, we adjust the way we market or we adjust the way we actually design the level. And if we identify it immediately, it takes the developer 2, 3, 4 weeks to actually do the change and make it live again because of the bug or something like that, right? How do you, or in your experience, what are the kind of levers that actually make sense to pull in real time?
Launch day changes. I release an item. It is apparently way overpowered. I let the players play with it for a couple hours. I say, oh gosh, this is like really ruining it. I'm getting bad press on the message boards. News and gaming travels fast, right? Like you don't really see that many advertisements for games. It's all done on a very like, what are these influencers playing? What's up on YouTube? What does this review say? You don't see a TV advertisement for video games at Super Bowl, maybe like for Call of Duty, like the biggest ones or something like that. But we can then in real time change the stats of items and stuff like that. The A/B test, was a kind of a good thing there. That's a real time thing. Like I don't want this server floundering for the next week while I go back and change it. But it's things like, and it's kind of forward thinking here, but we're working with customers right now to create more lifelike NPCs or non-player characters to give a very personalized conversation that feels way more real. So instead of you going up to someone, a tavern keeper in a game says, welcome, he would say like, hey man, how was that last quest? Or how did this happen? Or you played this thing in this other game 20 minutes ago. Here's an item as a reward for playing multiple games from the same company. Like those sorts of personalizations, that interaction with the models who are going to generate like, that text or that voice that NPC is doing are obviously the large language models and stuff like that, and very well-trained AI models. But the interaction has to be done in real time. So that's what we use. Kafka is just a pipe.
Is there work towards like offloading some things from the pipes? You talked about sort of like churn prevention and things like that. And one of your kind of simple things was like how many times have you failed in the last 30 seconds? That can be run on the phone, right? That's a check that you can run.
Very much so. Yeah.
So do you meet with these customers? Do you talk about these things in terms of, you're not getting a lot of data from this flag and you should implement this in your package that you're delivering rather than through our pipeline?
It's less of the fact that it could be run on the phone. Because most people are running that sort of logic at the game server, at the game client right now. And what you can't do there is create them a personalized offer. So there are, I just didn't have time to go into all of it. But I have, actually it's probably better shown in the Kafka interface. Yes, I can detect that they're getting frustrated on the phone. What I can't do is say, give this perfect offer to this person. And this offer is perfect because I know how much they want to spend. I know exactly where in the game they are. And I know the thing that they need to overcome this challenge. And I know how to price it. So I might sell the fire sword to someone for $5 because I know that when they're frustrated, every time they spend $5. But someone else might be like, no, I'm only spending 50 cents on something to get me past this next level in the game. So I can monetize much more effectively. I can monetize in a much more personal way. I can also collect the data. And I can then use things, my big brain systems doing the analysis to come up with these better offers for them and then generate the next best offer for them as well. So if I'm implementing that on the phone, they get the canned offer. You are having trouble with this. Here's the normal item that people use. It has nothing. It might already have that item in their inventory. Like it might be totally useless. You might be just totally whiffing on that sale. So we bring it in. We can do the big analysis on it. Create the perfect offer, the right price to the right person, the right geography, the right point in the game based on their past experiences, what they already own, and they'll buy. I mean, the buy rate on those offers is astronomically higher than the buy rate on the canned $1 for the fire sword to get past the whatever boss. Yeah, how much time we got left?
Yeah, one more question, but there'll be time at the end for networking.
Mhm.
Yeah.
You're talking about monetization, right?
Uh-huh.
You release a game, you want players to buy the game.
I'm having a little trouble
You
here.
release a game, you want the players to buy the game first, right? Like,
Uh-huh.
and what are the factors that you consider to make sure that the way you monetize the win-win situation for both the sides? Like, it's not too crazy, or what are the factors based on a game? Once you develop a game, what do you check in that to determine the cost of the game?
Right. So there are a wide variety of monetization strategies in gaming, right? I mean, there's the play the game for free, but you gotta eventually pay once you hit a certain level. Like World of Warcraft is doing that now. I can play up to like level 30, which is a lot of fun for absolutely free, but I gotta pay if I want to go past that. Or you can do it where you can grind through it if you want, but if you want to get through it faster and have more fun, you got to buy items and subscriptions to get you past. Or maybe there's more content or expansions. And then there's the upfront model where I pay for the game upfront, that price, and that might be mixed. You can mix and match all of these. But the actual pricing, like the upfront pricing on a game launch, is really heavily data scienced by marketing people. And it's not done with real-time data, so I don't really mess with that much. But it has a lot to do with lately on how much more the games are costing. Like their games, when we were kids, it's like, what, like $60 for a Super NES game. It's really expensive, right? But that price has stayed pretty consistent for a platform game. But now they're releasing their $70, $80, and then there's a $15 a month fee on top of them. And, it's just like pricing things in a retail store. They find the price point, they know when to put it on sale, and they know how to make their money back. All right. Thank you all so much.